Okay, this video is going to quickly walk us through solving equations with variables on both sides. For some vocabulary, what we first need to understand is that there are going to be three choices when you have variables on both sides of the equation. One solution equations are when the variable can be isolated to solve. This is when we're going to find the value that makes the equation true. This is what you have been doing. Okay, we are most familiar with this option. But now that we will have variables on both sides, you also have these no solution or many solution options. No solution is when there is no value that will make the equation true, and we'll see through some examples that the variables will cancel out and you will be left with a false statement. Many solutions is when all values will make the equation true, and when we're solving these, the variables will cancel out and you will be left with a true statement. There's no way to know just by looking at the equation which one of these three options will happen. You have no choice but to start solving to be able to identify which of these three is going to occur. Okay, so what we're going to be doing here is we're going to be solving by these two steps really, simplifying each side by distributing and combining like terms. We ended the last lesson with those sorts of problems, and then we will use inverse operations to isolate the variable. This is going to be a little bit different because the variable is now on two different sides and we're going to have to work to put those together. So let me work through this first problem with you. Okay, my first step is distributing. I have a set of parentheses here around the 3m plus 8 with a negative 2 out in front that needs to be distributed. The 7m and the minus 7 are not being distributed, so I just brought those down. When I distributed the negative 2, I got minus 6m and a minus 16 there. The right-hand side of the equation is staying the same. From always, after distributing, I'm going to try to combine like terms. So I have my variable term, 7m minus 6m is just going to be 1m, and then the negative 7 minus 16 will be negative 23. That's what I get from combining like terms. My right-hand side is the exact same. It's already simplified. There are no like terms. There's nothing to distribute on the right-hand side of the equation. So as discussed before, these two steps were the simplifying. Okay, I have distributed and I have combined like terms, so I am done simplifying and we are now ready to solve. Now for solving, we're going to be using inverse operations. So notice that I have a variable over here and I have a variable here. I need to move them together, and when we cross this equal sign right here, and sometimes I like to draw a line down there, I need to move this 4m over here. So I'm going to cross this purple bar. I'm going to cross the equal sign. And anytime you're going to cross the equal sign, we need to do inverse operations. So I'm going to undo that addition by subtracting 4m from both sides. When I do that, this is a 1. Again, I get negative 3m. The minus 23 will just come down, and that will equal 1, because the 1's going to come down, but 4m minus 4m here, those are going to be subtracted out. At this point, we should now have a two-step equation that looks very similar for you to be solving from the last lesson. I have one variable, it's on the left-hand side. I'm going to add 23 and divide by negative 3. My answer here, after adding 23 and dividing by negative 3, I got m equals negative 8. This is an example of a one solution equation because I was able to isolate my variable and find the value of the variable that would make my equation true. Now, the check would be plugging negative 8 back in to both sides of the equation. Everywhere you see an m, there needs to be, you're plugging in the negative 8 to make sure that we end up with a true statement. So let me go to a clean slide and then we'll do the check next. Okay, so now that I have my check set up here, this is my original equation. Remember, we got m equals negative 8. So everywhere we see an m, I'm plugging in a negative 8, and that's on both sides of the equation in my original problem. So what sometimes is helpful to do is actually go back through the original problem and put parentheses around all the variables so that way you know exactly where to plug in the solution that you got. Now at this point, all I need you to do is plug this very carefully into your calculator and hit enter, and then this very carefully into the calculator and hit enter, and hopefully we get the same answer. So I'm going to go ahead and do that really quickly. So even though the problems look longer and it looks like the check could take longer, as long as you're using your calculator correctly, it will tell us that we do get negative 31 equals negative 31, and the check is good, which tells me that my answer of m equals negative 8 is correct. In this next problem here, I do not have any distributing because there are no parentheses, but I do have some like terms to combine on the left-hand side of my equation. So I have 4n, a positive 4n plus 1n, which is 5n, and then I have this positive 3. So 5n plus 3 equals 2n plus 15. Notice that when I combined this 4n plus the 1n, this was all on the left-hand side of the equation, so I'm not doing inverse operations. I'm doing what I see, positive 4 plus 1 to get 5. Please don't confuse when to do inverse operations and when to simply combine like terms. So this one step is what took us to simplify. And now we will start solving. What I'm going to do first is realize that I do have this equation that now I'm going to subtract 2n from both sides, and that will bring all of my variables to one place on the left. 3n plus 3 equals, well, these two n's will subtract out, 2n minus 2n, so that equals 15. And right here, now we have that point where it's a basic two-step equation where I can solve by subtracting by 3, and then I will divide by 3. Because I have this 3n equals 12, divide both sides by 3, n equals 4, and I'll go ahead and take care of my check right now. So after plugging in the value of 4 everywhere that we see an n in the original equation, I plugged the left-hand side into my calculator and I got 23. I plugged the right-hand side into my calculator and got 23, which tells me my check is good, but my answer, please remember, is n equals 4. So this is another example of where we are simply dealing with a one-solution equation. In this problem, I'm going to go ahead and simplify very quickly just to start to move a little faster through these problems. Now what we may begin noticing here is that there's a negative 40 on both sides and there's a positive 5n on both sides. So what's going to happen here is that now that I'm done simplifying and I go to subtract my 5n from the right to move it over to the left, what happens to my n's on both sides is 5n minus 5n is 0, so I'm left with negative 40. And again, on the right hand side of the equation, 5n minus 5n is 0, and I'm left with negative 40. So bringing down the equal sign, I'm left with this statement, negative 40 equals negative 40. My variables have canceled out, and I am left with a true statement. Negative 40 does in fact equal negative 40. So because that is true, my answer to this problem is many solutions. When we have many solutions, there is no check because every single check would work. So this is the first example that we've seen where the variables are canceling out. They're subtracting out. When I try to put them together on one side of the equation, they add or subtract out, and I no longer have a variable, but I do have this true statement, negative 40 equals negative 40. I'm going to go ahead and move quickly through this, simplifying before we start solving also. So this problem I just went ahead and quickly solved because I realized as I was going through that my variables were not going to cancel out. So this is just a basic one solution equation. So k equals -6 is what I'm now going to check in my original problem very quickly. Again, plugging in -6 and then plugging that into the left-hand side into the calculator very quickly, and then very carefully putting in the right-hand side into the calculator also. Hopefully you get -4 for both of them, which tells me that my check is good and that k does in fact equal -6. Alright, in this problem I went ahead and started distributing right away on my right-hand side because it had parentheses. My left-hand side is already simplified. After distributing the -6, I got -6 plus, there's a plus there because a negative times a negative, plus 6x. Now I'm done simplifying. When I go to solve, by moving this 6x to the left-hand side by subtracting 6x from both sides, what I'll notice again, because my coefficients are being subtracted out, I have a positive and a negative version. 6x minus 6x is 0. So I just have 1 equals -6 because these 6x's on the right also cancel out. Well, now that I have no more variables, my variables have subtracted out, but now I have this statement of 1 equals -6. Well, that hopefully is very clearly false. Since it is very clearly false, the actual answer to this problem is no solution, because there is no value of the variable that makes the equation true. There is also no check. So no solution means that there's no check. So this happened when my variables canceled out, they subtracted out, but I was left with a false statement. Last problem, I'm going to go ahead and distribute on both sides, see if there's any like terms to combine, and then I'll figure out what sort of situation I have from solving. So in this problem, I had to distribute twice, once on the left and once on the right, but there were no other like terms to combine. So after I did my work in red, all of my purple work is now the solving. Notice again that when I did add the 16R to both sides, I lined up my R's to make sure that we understand that we're just doing this with the like terms. Subtracted 16 from both sides, and then I was able to divide by 28. After we do that first step of moving the R over to the left, again, we have this 28R plus 16 equals -40. You have a basic two-step equation that we're used to solving over and over again. So I got R equals -2, which I'm now going to check. After plugging in -2 into all of the original R values in the original problem, again, I plug this very carefully into my calculator and hit enter. Then I plug this very carefully into my calculator and hit enter, and hopefully we get the same answer of -8 equals -8, which means my check is good. But keep in mind again that my answer to the equation is actually R equals -2. Okay guys, this was a lot of solving steps, but it was all pretty much the same things that we've been doing before, just kind of putting it all together. So you want to make sure that you are watching this video as often as possible. The practice worksheet that you're going to start out with should all be one solution problems, so it should be very similar to the work that we've already been doing. Just remember to distribute and simplify first, and then start solving by moving the variables to one side using inverse operations, and then continuing with your basic two-step equations. Please, please, please rewatch this video as often as necessary to work through those examples. Thank you.